From the Chesapeake Bay Journal, your source for independent environmental reporting, this is Chesapeake Uncharted, the podcast that uncovers stories about the Bay region, its interconnected ecosystem, and the people who rely on them. I'm Jeremy Cox. On today's episode,
this snapshot in time is not what it's going to look like in the long term. It's not what it looked like in the past, and it's not what it's going to look like in the future. This landscape is actively changing, literally in front of your eyes, because of sea level rise and subsidence.
Often when we talk about climate change, we end up focusing on the built environment, and for good reason. Rising sea levels, increasing storms, and other climate shifts are endangering roads, homes, and businesses, representing billions of dollars in public and private investments. But what about the natural environment? How is it responding to our new natural order? Scientists are scrambling right now to uncover what the future holds for the planet's landscapes. Because seas are rising faster in the mid-Atlantic region than in many parts of the world, it's become a leading outdoor laboratory in this burgeoning field of inquiry. Among those sifting through the early clues is Karen Gadan, a coastal ecologist with George Washington University in Washington, D.C.
Yeah, it's true. This is a grand experiment that we're doing on a global scale. The mid-Atlantic has especially high rates of sea level rise, so I think of it as a window to the future of the, coasts of the entire world.
The underlying goal of this research is to do more than simply tally up the damage. Scientists like Gadan are actively searching for ways to preserve these landscapes. They're valuable to wildlife and people too. Salt marshes provide habitat for many species of birds and other wildlife. Barrier islands blunt the destructive power of storm surges. And coastal forests help shield waters like the Chesapeake Bay from pollution. But each of these iconic mid-Atlantic landscapes is under threat. During this season of Chesapeake Uncharted, we're examining climate change. It's happening here and now. Not just at the North Pole and Antarctica, we're talking about right here in the Chesapeake Bay region. With each episode, we're taking a close look at one slice of this new reality. Think of this as a snapshot in time before things get worse, when we, as a society, can maybe still change the future. Today, we'll check in on how climate change is altering our natural landscapes and what's being done to protect them. There are three types of terrain that bear our attention. All can be found on Delmarva, the peninsula that hugs the eastern side of the Chesapeake Bay. So let's slip on our wading boots and start the journey. First, a quick break.
Chesapeake Uncharted is brought to you in part by Greenfin Studio, offering marketing and communications services for a greener world. Their team combines strategy, creativity, and scientific insight, setting them apart when conservation, sustainability, and scientific organizations need help telling their stories. See what they can do for you at greenfinstudio.com.
Hello again. Today on Chesapeake Uncharted, we're visiting natural landscapes to see how they're holding up to climate change. Let's head first to the Blackwater National Wildlife Refuge in Dorchester County, Maryland. It is a wet place, and it's getting wetter. Since 1938, this federal refuge has lost about 5,000 acres of marsh as water rises and the marsh converts to open water, according to a Salisbury University study. That's about 16% of its total acreage. Tidal marshes are particularly vulnerable to sea level rise. These are the seemingly endless expanses of grass-like plants that border much of the Chesapeake Bay. They grow on mats of peat, lying only inches above sea level. It's a unique habitat. My favorite creature here is the periwinkle, a sea snail that spends its days climbing up and down stalks of marsh grass in perfect rhythm with the tides. But there are also blue crabs here, along with salt marsh sparrows and black rails. The salt marsh is vulnerable, but it's not defenseless. It has this hidden mechanism that could allow it to survive in a post-climate change world. But its success depends on many different variables. To understand what's happening, I traveled to the Blackwater Refuge on a pleasant morning in the fall.
So you can see some of the trees, a little bit higher ground. You can see they have more green to them. They're looking a little healthier. You can see one there that's
There,
recently browned
I met
out,
Matt
still has
Whitbeck,
its needles, but
the
they've
U.S.
all
Fish and
died.
Wildlife
It's
Service
recently
biologist
given away.
assigned to the
Sea
refuge.
level rise and subsidence. I feel like the whole idea of climate change and sea level rise is something that's very, I don't know, it's a hard theory for people to get their heads around. And what I like about this is somewhere where people can come and they can see it and they can understand the impacts on the landscape.
The legislative act creating the Blackwater Refuge was signed in 1933 by President Franklin Delano Roosevelt. It's a mosaic of salt marsh, tea-colored creeks, loblolly forests, and farmland. The remarkable Harriet Tubman spent part of her enslaved years here, working on farmland that now lies within the refuge. The refuge is also known as a wintering haven for thousands upon thousands of ducks, geese, and other waterfowl. As a result, it attracts another kind of species, wildlife photographers with their heavy telephoto lenses. The refuge is also popular with bicyclists. And let's not forget the third group of Blackwater enthusiasts, climate scientists. When you punch in the full name of the refuge into a Google Scholar search, you get more than 640 hits, 100 of them since just 2017. Blackwater is widely seen as one of the forerunners of climate change. You see, like in most parts of the world, water levels are rising in the Chesapeake Bay region. But unlike most parts of the world, the land is also sinking. The process is called subsidence, and it traces back to the end of the last ice age. When the glaciers retreated in what is now New England, the land to the south started settling, and it's still happening, at about 1/10 of an inch per year. In the low-lying land of the Blackwater Refuge, these changes are especially clear. To a certain extent, coastal marshes are naturally engineered to handle these kinds of changes, Whitbeck told me.
Sea level rise has been happening for thousands of years, right? Since the peak of the last ice age, sea levels have been rising in the Chesapeake. And so this is a process that's been going on for a long, long time. And many of the, really all of the tidal marshes in the Chesapeake that we consider, good, high quality habitat has been, evolved under sea level rise. So these marshes know how to form and persist for a period of time, given this process.
Since the 1930s, the amount of sea level rise has jumped from 3 millimeters in a typical year to 10 millimeters, according to Old Dominion University. Most climate scientists would say that gain is caused by an increase in greenhouse gases streaming into the atmosphere and heating the planet.
Now, it appears that it's happening much faster, and I think there's a lot of questions about how well these marshes can keep up with these higher rates of sea level rise and subsidence.
There are basically two things that can happen when a tidal marsh is confronted by sea level rise. Number one, it can drown. And that's what happened to those 5,000 acres we talked about earlier at Blackwater. The water came up, and the edges of the land eroded, and storm-driven tides washed over it more frequently. Add it all up, and it was enough to cause the mat, that platform of peat and muck, to fail. Whitbeck brought me out to an observation deck to show me how that process has upended the landscape. So this is what climate change,
This is the impact of climate change right here. So we did a number of years ago, we did a mapping project with Salisbury University to try to quantify some of these changes since the refuge was established in 1933. And they estimated over 5,000 acres of tidal marsh had converted to open water since 1933 when the refuge was established. But what was really interesting about that study is during that same time frame, almost 3,000 acres of upland has converted to tidal marsh. If you look to the south, you see this vast open water area, beautiful, but it's important to understand that when the refuge was established in 1933, everything that you see to the south, or nearly everything you see to the south that's open water now, was tidal marsh.
Now, it's important to understand that erosion and sea level rise had a helping hand here when it comes to destroying marsh plants. Well, it was more like a helping paw. Someone way back in the day thought it would be a good idea to introduce a South American rodent called nutria into these marshes. The idea was to make some money selling their fur, but nutria feed on the marsh root systems, killing them. The blackwater population peaked at around 50,000 in the 1990s, but thanks to decades of eradication efforts, those orange-tooth invasives have been nearly wiped off the landscape here. So to review, when the water rises, marshes may drown, but remember, that's just one of the two options. The second is the marsh's defense mechanism. As the tide pushes farther inland, the marsh moves with it. Because the elevations are generally higher as you move away from the shoreline, the marshes are traveling upslope, like salmon swimming up the current.
The landscape changes as sea level rises and as land subsides. That tidal wedge, right? So that tide range essentially moves upslope, and that habitat just constantly changes.
This is called marsh migration, and is absolutely key to the survival of this critical Chesapeake Bay habitat. But don't let the name fool you. These plants aren't growing little legs and transporting themselves to higher ground. Over the span of years, the plant's seeds are carried upslope by the wind and water, and their roots spread into new areas. Before you know it, an entire marsh has moved. But what is it moving into? Whitbeck took me to a different part of the refuge for that. Fair warning, things are about to get a little spooky around here.
What we have is we've got this edge where you have what we call ghost forest, an area that was forested habitat not that long ago, but because of sea level rise and subsidence, salt water has moved into that forested area, killed all the trees, and we call that a ghost forest.
When the salt water and the marsh plants move in, the pine trees undergo this transformation. They lose their needles. Some branches fall off. The bark weeps off in clumps. After a while, a shady forest becomes a cluster of trunks in various states of decay.
You see the majority of the trees are just standing dead at this point.
About 3,000 acres of the refuge's forests have already changed into marshland, and it's going to keep happening as long as the water keeps rising and the land keeps sinking, Whitbeck said. In many parts of the Bay watershed, land managers are working to preserve coastal forests, not for the forests themselves, but to make sure that marshes have upland places to migrate. If there are roads or buildings behind that marsh, the first option is the only option, drowning in place. Even if the marshes can be saved, Whitbeck and other conservation-minded folks are worried that they won't be very good quality.
The challenge we have is with Phragmites, and that's a non-native type of grass that grows in these higher tidal marsh habitats. It's anywhere from 6 to 8 foot tall grass, and it grows in dense monocultures. And when this grass takes over, it really reduces the amount of wildlife that'll utilize one of these tidal marshes.
The most notable loss related to marshes could be the eastern black rail. Last year, the federal government declared the bird species threatened, in part because of its dwindling marsh habitat. On nearby Elliott Island, where the tiny black rails numbered in the hundreds as recently as the 1950s, scientists were only able to count one specimen each year from 2012 to 2015, and none in 2016.
With the unchecked spread of Phragmites, the loss of historic, high-quality habitat, and the lack of new habitat being formed through sea level rise and subsidence, it's easy to see species like black rail and salt marsh sparrow disappearing in the Chesapeake Bay in coming decades.
Land managers in the Chesapeake region are working with state agencies and the U.S. Army Corps of Engineers to take increasingly aggressive actions to preserve marshland. They're stabilizing shorelines to block storm surges from washing inland. They're installing huge stone jetties to reduce the corrosive effects of waves and tides. And in some places, they're dredging up muck and spraying it on top of the marsh mat to raise it up. Blackwater completed a marsh restoration project in 2017. At 40 acres, it was the largest ever attempted in the Chesapeake region. It added about 4 to 6 inches in elevation to a low-lying marsh, which was replanted afterward. Whitbeck told me he hopes the effort provides a roadmap for other marsh projects in the region.
And at least in the near term, it looks like it's been very successful. The vegetation has rebounded very quickly, but the true success of this project will come to light in coming years as monitoring data helps us know whether these marshes are really building elevation like they should.
Let's head down the peninsula a few miles to Somerset County to see what one team of scientists is learning about marsh loss. We'll do that right after this break.
Hi, this is Laura Lutz, editor at the Chesapeake Bay Journal. I hope you're enjoying our podcast, and I'd like to invite you to join the community of Bay Journal readers. If you care about climate change, wildlife, clean air, healthy communities, and of course the Bay and its rivers, you'll find news you can use at the Bay Journal, along with some great ideas for outdoor travel. Our subscriptions are free. Check us out at bayjournal.com and click on subscribe to start receiving the best independent environmental news in the Bay region.
Welcome back. On today's episode of Chesapeake Uncharted, we're exploring how the natural landscape is evolving due to climate change, and what's being done to save these places from the rising tide. Now let's journey to Deal Island, a small community just north of the Maryland-Virginia line on the Delmarva Peninsula. Deal Island is a hub for watermen. The waterfront is where all the action happens. The marina is stocked solid with dead-rise boats, loaded with crab traps or plastic oyster bushels, depending on the season. It's here, around the mucky edges of the community, that researchers have been unlocking the secrets of the tidal marsh in the hope of speeding its preservation.
My name is Karen Gadan. I'm an assistant professor at George Washington University in the Department of Biological Sciences, and I'm a coastal ecologist, and I've been researching the response of coastal wetlands and coastal forests to sea level rise.
Working with a Chinese doctoral student named Man Qi, Gadan began her work with a question. What if there was a way to detect that a marsh is about to drown before it happens? They found their answer in the plants themselves.
It's easy to look at these ponds and say they're expanding, the marsh overall is getting wetter, but you don't really see that pattern until the ponds are already there. And we found by looking at the vegetation, you can actually predict that the ponds are coming. So we found this as an early indicator of pond formation and habitat loss.
A little botanical background first. Marshes are populated by a mixture of plants. Some prefer drier conditions, some wetter. Using satellite photos, Gadan and Qi were able to observe changes in the landscape over time on Deal Island. When water-loving plants moved into a certain area, it was a cue that it was about to become open water. The Army Corps is already using their work to guide a marsh restoration project set to begin in late 2021 in the Deal Island Wildlife Management Area. Okay, let's slog a little farther down the Chesapeake coastline and cross into Virginia. Marsh migration and ghost forests are a reality, not just for wildlife, but for homeowners as well. In this next segment, we analyze the human element.
My name is Miriam Riggs. I live here. This area is called Cashville. It's outside of Onancock, Virginia, out at the mouth of the creek. I'm on the south side of the creek, right where it hits the Chesapeake Bay. So it's by nature a very low spot. And It's getting lower all the time. But I love it here. I've been here 22 years now.
Riggs makes a living as a designer and artist. She has a home and a small studio on her property, which she shares with, you guessed it, an extensive marsh and ghost forest. The haunting terrain was one of the things that appealed to her about the property.
Rather than flee from challenging natural circumstances, I have often, and I'm not a risk taker, believe me, but I'm often drawn to the dynamic nature of the power of these natural forces.
Riggs doesn't make a lot of money as an artist, so the property's relatively low asking price, especially for waterfront acreage, was also a draw. But within months of moving in, she got a hard lesson in the perils of living along the water.
I bought the place in December, then the following September, Hurricane Floyd hit. That was in 1999, and I got flooded pretty bad. Pretty bad. The house was declared a total loss, and I had about 2 feet of water in the kitchen, that kind of thing, all on the first floor. Everything on the first floor got just saturated.
It was a nightmare, but Riggs was determined to stay where she was. Despite the house being declared a total loss, she used her flood insurance and some FEMA money to fix it up and move back in. Not long after, she heard about hazard mitigation grants being offered by FEMA to raise homes in flood-prone areas. She applied, and the federal agency covered 95% of the nearly $100,000 cost of elevating her home by 4 feet. Since then, Riggs hasn't had a problem with her home flooding, but the water still overflows from the bay with what seems to be increasing frequency, and she has to deal with the consequences. Sometimes, she has to park her car down the street on higher ground to keep it from getting flooded. All of the fruit trees she inherited from the previous owner have died. When Hurricane Sandy hit in 2012, it washed in a thick blanket of sediment. Her art studio got inundated, and she had to rebuild it on the other side of her property.
Where my studio is located now, it's on the edge of the pine woods, but the pine trees are starting to die and just fall down. In fact, on Christmas, I guess it was Christmas Eve night, a pine tree fell down and knocked off the railing of my deck here at the studio. It's just another little reminder that, the forests are dying. Yeah.
The marsh, is that heading upland? Is that coming your way at all? Do you notice a difference there?
Oh, definitely. Because it really is literally right up on the edge of the yard now. And it didn't used to be quite that menacing or threatening or close.
Over the years, she has thought of leaving, finding a place in town. She's 65 and still healthy. She feels she can adapt, but she worries about what it'll be like as she gets older, fighting 2 inevitabilities at once: age and climate change.
I'm okay with difficulty and using some ingenuity, et cetera, but I'd rather not be facing this heading into my retirement years.
But Riggs hangs on. This brutal landscape is often the inspiration for her work, and she doesn't think it's likely she could afford to live by the water anywhere else.
It is a unique landscape, and now that I know what it represents, and it has more relevance to me, and I almost, in some sort of way, feel more driven to stay on and continue to document this.
We have seen how rising seas, erosion, and sinking land are reshaping the natural landscape around the bay. But what about a slightly larger body of water? Okay, a much larger body of water. The Atlantic Ocean. For our last story, let's go down to the very tip of the Delmarva Peninsula. Yeah, and there's the Chesapeake Bay Bridge tunnel over there.
Yeah.
This is the end of the bay, huh?
This is the end of the road here.
It's a tad foggy this morning at Wise Point, but that will burn off shortly, revealing an endlessly blue sky. It is indeed the end of the road, at least for the Chesapeake Bay. This is the terminus of its 200-mile journey, where its brackish waters finally merge with the full-on brine of the ocean. I'm here with some folks from the Nature Conservancy, which owns or manages 40,000 acres of land on Virginia's eastern shore.
Very cool. Looks like we've got a fine vessel here for us today.
This is the Betty May. It's a 23-foot Carolina skiff, and most of the work we do in these flat-bottom skiffs.
That's Alex Wilkie, a conservancy scientist. We get to go on a boat because there's no other way to reach our last natural landscape. Our interest lies in the Conservancy's holdings that, when combined with state and federal lands, comprise 80 miles of undeveloped coastline.
Where are we here?
So we've just left the Wise Point boat ramp, which is at the Eastern Shore of Virginia National Wildlife Refuge, and we're headed north along the Inside Passage, which is the navigation channel that runs north to south along the seaside of the Eastern Shore. And we've got Raccoon Island to the east, we've got the mainland of the Eastern Shore to the west, and when we come out of the marsh up here, we'll be looking sort of north into the vast Barrier Island lagoon system that borders the entire Virginia portion of the Eastern Shore.
And this is rather remarkable area for its size and the fact that it's undeveloped, right?
Absolutely. So we have between where we are and about 80 miles to the north of us is essentially in some type of conservation ownership. We often call it the last coastal wilderness remaining on the Atlantic coast because it's such a big stretch of undeveloped coastline that's essentially functioning in its natural state.
All along this stretch of coastline, the mainland is protected by a string of barrier islands. Barrier islands are found in front of about 15% of the world's coastlines. You might have visited one on vacation. The Outer Banks in North Carolina, Sanibel Island in Florida, or maybe Assateague Island straddling the Maryland-Virginia border. They're all barrier islands. They're different for a few reasons from your garden variety islands.
Barrier islands are different in that they have the ability to move landward with the sea.
This is Justin Schaller, a doctoral student at the Virginia Institute of Marine Science, who has studied the chain of barrier islands on the eastern shore of Virginia extensively. He's particularly interested in their underlying geology, how they formed. Here we have another example of nature just rolling with the punches. Barrier islands can migrate just like marshland when confronted with rising seas, Schaller says.
So as sea level rises, the barrier islands, when left natural at least, have this ability to push sand over themselves. Really, it's waves and storms that are doing that action, but the barrier island itself moves landward and migrates, and it can keep pace with rising seas.
What distinguishes barrier islands from what we'll call non-barrier islands is that, at least hypothetically, they have this ready supply of sand at their disposal. But as we saw with the salt marshes, there are limits to nature's adaptability, and the consequences are already plainly visible.
Way to go, Kelly. God.
Just gonna knock this thing over.
It's my job to break stuff.
Back to my boat trip here.
To see where all these birds are basically following that water's edge. They're being pushed up together.
On the edge of the mud flats there.
We've motored out to the ocean side of the peninsula, but the water is glassy. The waves can't reach us because they're being blocked by barrier islands. There are a couple of off-the-grid houses and fishing shacks. Otherwise, pine trees are the only vertical relief, but many don't seem to be doing too well.
And this is Skidmore Island right here, another good example of where you can see the water levels have been encroaching along the edge of this forest here, and eventually, you'll see those pines are probably going to fall into the water and don't have much longer to go, I imagine.
How can you tell the water's encroaching?
You can just see where it's eating away at that line of vegetation, and when you look closer, you can see the dead trees interspersed with the live ones as they succumb to the levels of the salt water.
As we've discussed, seas have been rising for thousands of years already. But what happens when you mash down the gas pedal on those changes, like we've done with climate change? According to Schaller, it's hard to know where that breaking point lies, and it's likely to be different for each island, depending on whether it can access more sand from below.
So we know that there's some limit on their ability to keep pace with sea level rise, and sort of where the biggest research questions remain in the world of coastal geology, at least as it focuses on barrier islands, is what are those limits? So we know that there are some records off of, for example, the South African coast of barrier islands that have drowned in place probably about 8,000 years ago or so. And the questions are, what were the rates of sea level rise at that time?
There's more at stake than just the positioning of a few billion grains of sand here. Many birds and wildlife have adapted to the whims of the barrier island ecosystem. With sea levels rising, the future for some of them is unclear.
That chatter is something that, not everybody gets to hear that. Like you see all these pictures of flocks and you see shorebirds, but I just feel like that's a sound that a lot of people don't get to hear because you don't get that close to them.
Most of the shorebirds that nest in coastal Virginia appear to be weathering the changes reasonably well. One notable exception is the laughing gull, a medium-sized bird that looks like it's wearing a black hood over its head. Its neck and belly are white, while its back is dark gray. Since the early 90s, the number of nesting pairs counted in Virginia has plummeted from 55,000 to just 20,000. The main cause is climate change, wreaking havoc with its habitat.
These birds nest on the rack material, the dead vegetation that gets pushed up onto the marshes, and they can withstand a certain level of flooding because the rack will move up with the water and then come back down. And sometimes, the eggs can withstand that, and they'll stay put, and the birds can still incubate, and they successfully hatch. Another dynamic that we're seeing is if we have higher tides and more frequent high tides in the springtime, and that rack mat gets lifted too high up off the marsh, you can imagine it just floating away into the coastal bays.
Oh no.
Yeah, and so those birds, you can lose entire colonies on one tide by the whole thing just floating away.
Well, that's heartbreaking.
It is heartbreaking.
What's likely to happen, experts say, is that developed barrier islands will need to replenish the sand along their beaches more often as the sea rises. In some areas, they will have to bring in more sand so often that it will eventually become no longer economically feasible to keep up the fight, and that will spur debates about which places we ought to save and which ones we should abandon. Undeveloped barrier islands, meanwhile, are better equipped to survive than their developed counterparts. That's because, with no condos or boardwalks in their way, they can continue rolling landward, Schaller says. Maybe some will, and some probably will be lost to the rising tide. But Schaller is optimistic about their future.
There's reasons to be worried about sort of a doom and gloom scenario. These islands could break apart like we saw, right? And inlets could open up. But if they can access some of the layers of sand that are underneath them, that gives me hope that at least over nearer term human timescales, decades up to maybe a century from now, they might still be here. They might still function as barriers for the communities on the Eastern Shore.
Thanks to Greenfin Studio, which combines creativity and communication savvy with scientific insight. Visit greenfinstudio.com to see how they can help your organization engage a wider audience. Chesapeake Uncharted is brought to you by the Bay Journal, your source for independent environmental news in the Chesapeake region. Production for this episode was by me, Jeremy Cox. The story was edited by Laura Lutz. Our marketing and advertising director is Jackie Kane. You can find more episodes of Chesapeake Uncharted on your favorite streaming service or at chesapeakeuncharted.com. If you like what you're hearing, sign up for a free Bay Journal news subscription at bayjournal.com. Until next time, this has been Jeremy Cox. Take care.